Okay guys, let's get in depth of boundary wall conditions. Now in case of boundary wall conditions, one which we have seen is node has to be at closed end. As here we see node at closed end, antinode at open end. Now as we see antinode at open end, in case of pipe open at both the ends, antinodes are at both the ends. Alright, open ends. Antinodes are at both the open ends. Alright, done. The third one which we are doing now is antinode at 0.3D above the open end. When you check out over here, you will find the antinode of air column vibrating in pipe is slightly above the closed end. Alright, here also we find it is slightly above the closed end. Here also it is slightly above the closed end. That distance from closed end is 0.3D. Now if we assume this to be capital L to be length at which the antinode ends, and if small l is the length at which the pipe ends. Alright, so the difference between L minus L would be 0.3D. And what is this D? D is diameter of the pipe. Alright, so that correction has to be applied in all the formulae that we had seen so far. So antinode at 0.3D above the open ends that we saw, where end correction is 0.3D, E being end correction, D being diameter of the tube. Alright, reason why antinodes are formed at a distance 0.3D from end of pipe is because the air column is freer there than inside the pipe. Alright, so it chooses to form antinode at 0.3D above the closed pipe. Alright, here what I have shown is only for fundamental or harmonics. Alright, so vibration of air column in pipe closed at one end, and in this case vibration of air column in pipe open at both the ends for fundamentals. Alright, or first harmonic. Same has to be applied also to all the formulae that we have derived for second and third harmonic and for open and closed pipe both. Alright, so let's check it out. So we revisit. So the formula finally that we had derived was, now this is first harmonic, second harmonic and third harmonic, where we had already done the derivation. And the formula that we had derived for fundamental or first harmonic was V over 4L. Now what we have got to apply error correction. So when we apply error correction, instead of L, it would be L plus E. This was L and this was E. Alright, this was E. So L plus E. In either case, we have got to apply, whether it be pipe closed at one end or pipe open at both the ends. Got to apply to both. So it would be this length plus the end correction. Alright, plus the end correction. If you take it from here to here, it is L plus the end correction. If you take from here to here, it is L plus end correction. Okay, in all the formula that you would be seeing now, instead of L, capital L, it would be L plus E, the end correction. Alright, so that's what it is. So here the formula was this. Instead of that, it became now L plus E. Now again here, the formula that we had derived was 3 into V over 4L. So it became 3V over 4 into L plus E. Alright, similarly here also it would be 5 over, what we had derived was 5 into V over 4L. So it would be 5 into V upon 4 remains the same, L plus E. Alright, when we come to pipe open at both the ends, obviously there would be two end corrections. Alright, so that's the reason why this was our formula. Instead of L, we replaced it by L plus 2E, end corrections for both the sides, here as well as here. Alright, so similarly we would find that all the formula L, capital L, has been replaced by L plus 2E. L plus 2E. So this becomes our final formula with n corrections and following the boundary conditions. Okay. Now we are done with open and closed tube. Basically I did not do the n correction initially just to make it simpler, alright, to understand as well as to explain. So now you know how the n corrections are to be applied. Okay, all the best.